Welcome back friends, I am Rajdeep Acharya back again with another new lecture, and in this lecture I am going to talk about mass spectrometry graph analysis. So let's get started guys. So basically the graph of mass spectrometry looks like this. So it is actually a line and it is actually another line. It is actually x bar, it is actually y bar, it is actually 0, it is actually x, and it is actually y. So this is actually the diagram of graph of mass spectrometry. Now guys, we need to know that what actually those lines are actually stand for. So basically the x bar to x, this line actually stand for mass by charge ratio. So basically x bar to x, this line actually stand for mass by charge ratio guys, and the y to y bar, this line is actually stand for percentage abundance. So basically the y to y bar, this line actually stand for percentage abundance. Okay guys, and this line x bar to x, this line actually stand for mass by charge ratio. Now guys, suppose it is actually A is actually a sample protein. A is actually a sample protein, and the A is actually subjected for mass spectrometry. So now you have to perform the mass spectrometry with sample A protein. So basically at first, when you will put the sample A protein in a mass spectrometer, the sample A protein at first it will be subjected for ionization. So at first in ionization state, the sample A protein, the electron will be heated on sample A protein. The electrons will be heated on sample A protein, and the sample A protein will be turned into A plus molecule ion. So basically the sample A protein in ionization state, the electrons are heated on sample A protein, and the sample A protein lost its one electron and it turned into A plus molecular ion. So look at guys here look at guys here, 1 plus is present on A. So basically 1 plus, that means charge is 1. So basically here we can say the charge of A is actually 1. So now this is actually charge of A, molecular ion. So now here in the place of Z we can write the charge of molecular ion A. So if we write here the charge 1 here, so we can get m by 1. M by 1, we will get m by 1. Okay guys, so m by 1 equals to m. M by 1 actually equals to m. So now we can conclude that the x bar to x, this line actually stand for molecular weight. This line actually stand for molecular weight. So now x bar to x is actually stand for molecular weight. So now I hope guys, now you have known that how actually the x bar to x, which is actually denotes that mass by charge ratio, actually the x bar to x denotes the molecular weight. Okay guys, now guys suppose the molecular weight, this line is actually 1, 2, 3, 4, 5, 6, 7. Suppose guys the molecular weight, this line is actually 1, 2, 3, 4, 5 to 7. It can be 100, 200, 300, 400, 500, 600, 700. It also can be 1000, 2000, 3000, 4000, 5000, 6000, 7000, depending on the molecular weight of sample. that is subjected for mass spectrometry. So suppose this is actually 1, 2, 3, 4, 5, 6, 7, 7, and suppose guys, and suppose in the after the performing mass spectrometry, you guys have got some lines. You guys have got some lines on graph. You guys have got some lines, something like this. So you guys have got some lines on graph. So what does these lines are actually depicting? Why they are in these places? So now at first we have to know why these lines are on this molecular weight line and why these peaks are so high and why this peak is so low. At first we have to know this concept. So basically, look at this line. Look at this line. Okay guys, look at this line. This line is actually present on 4. That means this sample has 4 molecular weight. This line is present on 5. That means this sample has 5 molecular weight. This line is present on 1. That means this sample has 1 molecular weight. This line is present on 2. That means this line has, this sample has 2 molecular weight. And now we will talk about the percent abundance. Look at the peak of those lines. This is the highest peak among 4 lines. This is the second highest. This is the third highest. This is the fourth highest. The last. So look at this peak. Look at this peak, guys. So basically, the peak of those lines actually depicts the intensity. So the peak of those lines actually depicts the intensity of the sample. That means this sample is present in higher amount. This sample is present in lowest amount. Maybe this sample is having much more molecular weight 5 than the 4 molecular weight sample, but this sample is present in highest amount than this sample. That's why the peak of this line is highest. So now guys, you may have question that how you will determine the molecular ion and fragment ion, because all we know that after ionization, when this molecular ion will go through the magnetic field, it will actually divide in some small fragment ion. So now this molecular ion fragmented in some small fragment ion. Now the molecular ion is now fragmented in some small fragmented ion. So why they are actually fragmented? Because when they will go through the magnetic field toward the detector, they need to be stable mode, because the molecular ion is not a stable mode. It has already lost its 1 electron. So this is why the A plus, the molecular ion, is not a stable mode. So it is not able to go through the magnetic field toward the detector. So that's why it needs to be stable. That's why it is actually dissociating in some small fragment ion. Now it is able to go through the magnetic field toward the detector for this graph, because after the detection of this small fragment, we will get a graph. So now you may have the question that how you will know the molecular ion and how you will determine the fragment ion in this graph. Maybe you have the question. So now the answer is, guys, suppose I remove this. So the answer is suppose guys the molecular weight, suppose guys look, suppose this is actually a line, this is another line, this is another line. Okay, these are the three lines. Okay, so now look at guys, the molecular ion will have the highest molecular weight than the fragmented ion. So basically here 6 is the highest molecular weight, then 5, then 4. So the molecular ion will have the highest molecular weight than the fragmented ion. So we can conclude that the molecular ion will be 6. It will be the molecular ion. 6 will be the molecular ion and the fragmented ion will be 5 and 4. It is actually the rules. So now you have learned how to detect the molecular ion and how to detect the fragmented ion in a graph. Now guys, now we'll move to the problems. Guys. So suppose guys in examination your teacher will give you some sums from this graph analysis of mass spectrometry. Suppose your teacher have given you a graph something like this. It is actually x bar, it is actually y bar, it is actually x, it is actually y, and here are some molecular weight 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so these are the molecular weight. These are the molecular weight, and this is the intensity. Intensity, I mean the percent abundance. That means the amount of sample which is present. So now if your teacher have given you that, suppose your teacher have given you graph something like this. Suppose your teacher have given you a graph something like this, and your teacher have given you 3 protein. Protein A, B, C, 30, and D, E, F, G, H, I, 40, and Y, X, Z, Y, X, okay, Y, X, 50. Protein B, protein B is A, B, C, 30, and D, E, F, G, H, I is actually 70, Y, X is actually 90. I mean it is protein B, and also protein C. Protein C is actually A, B, C is actually 10, and also D, E, F, G, H, I is actually 60 and X and Y is actually 70. And your teacher asks you to solve this question. Your teacher tell you that you perform a mass spectrometry of a unknown sample of protein after tryptic digestion. So basically trypsin is actually a enzyme which actually digests big protein sample into small fragment. So basically suppose it is your unknown protein, guys, it is your actually unknown protein and these are the fragment of protein. That means it is actually your unknown protein and after tryptic digestion you have got some fragment of protein like A, B, C is a fragment, D, E, F, G, H, I also a fragment, Y, X is also a fragment, and also these are actually the fragment of protein that we have got after the tryptic digestion of this unknown sample protein, and we put those fragments into the mass spectrometry for mass spectrometry graph analysis. And after the graph analysis you have, after the performing mass spectrometry, you have got this graph and your teacher can give you those values like ABC fragment has 30 value, 30 molecular weight. So these are actually the molecular weight, molecular weight, molecular weight, molecular weight. So molecular weight in Dalton. So basically your teacher have give you those unknown proteins, 3 protein sample and ask you that which protein among those 3 protein is your unknown protein. Your teacher have give you the fragment of those protein after tryptic digestion, and also your teacher have give you the molecular weight of those fragment. So now if you look at this graph, here a line is on 3, another line is on 40, another line is on 50. So here you can see that the highest line is on 40. That means this fragment is actually long among those two lines, these two lines. So this sample of this line is actually highest line, highest peak, having highest peak. That means this fragment is actually large fragment among those two lines, those two fragment. So here you guys can see that DEF GHI is actually the largest fragment. So it is clear to us that DEF GHI is actually this fragment. So and also this fragment is actually the moderate among those two fragments. So basically it is actually ABC fragment. ABC fragment is ABC fragment, and it is actually the smallest fragment among two fragments. So basically Y and X is the smallest fragment after the digestion of protein A by trypsin. So basically Y and X is actually the smallest fragment, that means this fragment. Now we have to look at the molecular weight, guys. Look at this. This ABC fragment is placed on 30 molecular weight. This DEF GHI is present on 40 molecular weight, and the YX is present on 50 molecular weight. So if we look at these 3 molecular weight fragment of the unknown protein sample, we can see that ABC is present on 30 molecular weight. One condition match. And DEF GHI also present on 40 molecular weight. Here also it is present on 40 molecular weight. Here DEF GHI present on 70. Here DEF GHI present on 60. So this condition also match. Now Y and X. Look at this. Y and X also present on 50 molecular weight. Here Y is present on 90 molecular weight, and here Y and X is present on 70 molecular weight. So here we can see that Y is present on 50 molecular weight of this protein A. So this condition also match. So we can say that the unknown protein that we have performed in mass spectrometry and after tryptic digestion and the graph we have got, So from this graph we can say that our unknown protein is actually protein A. So this is actually how we can actually calculate the graph of mass spectrometry. It is actually very easy, guys. If you actually practice this, you will get the master of this topic. Thank you so much, guys, for watching. I hope you guys have learned how actually we can calculate the graph of mass spectrometry. Thank you so much, guys, for watching this video, and also like this video, share this video among your friends who are in need of this topic, and also subscribe this channel. And in upcoming days where we will come with many more CSIR net topics. Thank you so much.